Alright, welcome to the lunchtime video. I've got to, let's see here. So, right, so it's going to be a new topic today. Okay, so let's see what topic it's going to be. Okay, we're still going to be talking about MPLS, but I finished up, so unfortunately I didn't exactly finish up FRR. I wanted to do an example, but my lab had a problem where the existing virtual machines couldn't leave Triton mode for some reason, even though they were configured to. So the only way to resolve that issue would have been to delete those VMs and create new ones that didn't have those issues. But I decided to just move on since I had already given it 9 videos. So the next topic is going to be node and link protection. So I'll make my notes folder. I'm tempted to go back and do it. I think there might be value in that just because it was such a clear, all-encompassing exercise, and I'm sure that it's pretty much exactly what's going to be on the test. Like that exact topology is probably going to be on the test, but I'm going to be taking the tests very, very soon, so I want to make sure I cover everything. Okay, this is still a high availability technique, but it is node and link protection. Okay, so yep, everything looks good there. Alright, so let's start it off the same way as every other one. We're going to be using the help apropos to see if I can learn about this. Okay, and I think I'm going to delete this whole topology and just even start the help apropos with a brand new one. Well, you know what? Just for the sake of time, I won't do that quite yet. Okay, let's just get some of the documentation up beforehand. Okay, so here we go. Help topic, MPLS node link protection. This is exactly what I need. Okay, so before doing anything else, I think I'm just gonna read that. Actually, I'm gonna do one thing before that. I'm gonna verify that I uploaded the last video. I'm pretty sure I did, but it would just not be cool to not do that. So how do I? Okay, there we go. So yep, here's the last video, 9. Yep, so everything's good. All right, so I'm going to read this documentation, then take a quick break, come back, maybe find a good online resource. Configuring node protection or link protection for LSPs. When you configure node protection or link protection on a router, bypass LSPs Let's see if I can get a cleaner printout of this. Bypass LSPs are created to the next hop or next hop routers for the LSPs traversing the router. You must configure node protection or link protection for each LSP that you want protected. To extend the protection along the entire path used by an LSP, you must configure protection on each router that the LSP traverses. To configure node protection on a router for a specified LSP, include the node link protection statement. Node link protection. You can include this statement at the following hierarchy levels: edit protocols, MPLS, label switch path, LSP name. I don't think there'll be logical systems on the exam. To configure link protection for a router or for a specified LSP, include the link protection MPLS statement. You can include this statement at the following hierarchy levels: edit protocols, MPLS, label switch path, LSP name. Note: to complete the configuration of node or link protection, you must also configure link protection on all unidirectional RSVP interfaces that the LSPs traverse, as described in configuring link protection on interfaces used by LSPs. Okay, so let's do another search. We'll match on protection. Okay, so yep, we've got lots of hits. Let's see if there's anything for RSVP. We do have one hit here, but I'm not sure. Here we go. So yeah, let's just take all of this and then go and trim it down. Okay, so this, we're definitely going to need this one here. I think this should be interesting here. These aren't relevant. This is going to be very relevant. This we've already got on the top. I think this might be relevant. This is ISIS. It's not related to MPLS. And neither is this. I am kind of curious. So yeah, we'll get rid of the OSPF. That's not going to be necessary. And then we'll start with the ISIS and see if that's going to be relevant. I wouldn't think it would be, because that's the IGP, and we're learning about MPLS here. But yeah, let's see what there is. Yeah, so this looks like something you can do for ISIS. So it's not relevant to this part because we're working on MPLS at this point. Although this does have MPLS on it. Ooh, I do like that it has the example of the load balance ACL on there. Okay, so yeah, I think I'm gonna, let's see here. Yeah, I'm gonna get rid of this last one, and then these are just gonna be the resources that I will use. So I already read this one here, so this one's gonna be next. I'm gonna need to take a quick break. I'll be right back, and then get to work on that one. Alright, I'm back and I'm recording, so I will minimize this, not close it, otherwise I wouldn't be recording. And we'll go through and look at the rest of these. So this is the example, so I think this is what I'm going to do, and then once I've finished this, move on. So yeah, so I'll set up an aggregated interface, and then I'll set up okay, well that's for, that doesn't look like it's related to MPLS, so I might actually want to delete that one. Let's take a look at just what all of the, yeah. So link protection just really seems like it's just having a backup link ready to go. And you can do that for a path through IGP, you can do that through a particular interface in an aggregated Ethernet bundle, or you can do that for an MPLS LSP. It's really just one concept that can be applied to different things. Yeah, so this here is going to be relevant. These two are not relevant to, I mean, it's relevant just to learn about link protection and the concept of it, but what we're interested in is how it is applied to MPLS LSPs. So disabling node protection for bypass LSPs, you can disable node protection on the RSVP interface. Link protection remains active. When this option is configured, the router can only initiate a next hop bypass, not a next hop bypass. To disable node protection for bypass LSPs, include the node protection statements, node protection. You can include this statement at the following hierarchy levels. Okay. So yeah, everything seems pretty good here. So I'll just leave those up, and we'll do a Google search and try to find an example, and hopefully I can keep this this short. Okay, so yeah, it looks like I won't even need to do a new. So I think I'm only going to give this one video because it seems pretty simple. So and then I'll just be doing what's on here, and hopefully we can see that work. Because even though there are problems with Triton mode, I do have an LSP up right now. So configuring node link protection is a two-part process. The first part involves configuring node link protection for any LSPs traversing the protected node that require use of the bypass path. The second part sets link protection in the outgoing RSVP interface on routers in the LSP. To configure node link protection, follow these steps. In configuration mode, go to the following hierarchy level. Okay. And then it's just a knob that you can toggle. And that's really all there is to it. But it looks like you can put it under RSVP and the path as well. So the following sample output shows the configuration of a node link protection on Ingress router R1 in the network shown in many-to-one or link protection. The sample output shows the configuration of node link protection for an LSP. After node link protection is configured, bypass Paths are signaled to avoid the protected link or node in case of failure. Having bypass paths available does not in itself provide protection for LSPs that traverse the protected node. You must include the node link protection statements on the ingress router for each LSP that will benefit from the bypass path. Oh, okay, here's another one that looks pretty good. Like if I could just pin up this topology and get everything to work, I think I'll basically have done the test. So that's going to be a good thing to go back and do at some point. Many-to-one link protection, facility backup overview. Many-to-one facility backup is based on interface rather than on LSP. While fast reroute protects interfaces or nodes along the entire path of a LSP, many-to-one protection can be applied on interfaces as needed, as shown in Figure 1. In Figure 1, a bypass path is set up around the link to be protected 10.0.12.14 using an alternate interface to forward traffic. The bypass path is shared by all protected LSPs traversing the failed link. Many LSPs protected by one bypass path. In Figure 1, two LSPs, LSP1-R6-2-R0 and LSP2-R1 to R5, are protected by one pre-established bypass path from R1 to R2 through R7. Both LSPs have strict paths configured that go through interface FE010. On router 1, the interface 10.12.13 has link protection configured that protects the next hop 10.0.12.14. Link protection, many-to-one, or facility backup allows a router immediately upstream from a link failure to use an alternate interface to forward traffic to its downstream neighbor. This is accomplished by pre-establishing a bypass path that is shared by all protected LSPs traversing the failed link. A single bypass path can safeguard a set of protected LSPs. When an outage occurs, the router immediately upstream from the link outage switches protected traffic to the bypass link, then signals the link failure to the ingress router. Like fast reroute, link protection provides local repair and restores connectivity faster than the ingress router switching traffic to a standby secondary path. However, unlike fast reroute, link protection does not provide protection against the failure of the downstream neighbor. Link protection is appropriate in the following situations. The number of LSPs to be protected is large. Satisfying path selection criteria, priority, bandwidth, and link coloring for bypass paths is less critical. Control at the granularity of individual LSPs is not required. Okay, so this seems like kind of something you would use for a large number of LSPs. Alright, let's try entering the commands. So unfortunately, it almost looks like I'm going to be kind of running out of things to do for this topic. It looks like a pretty simple topic. So let's try entering the commands. So I'm going to go configure private, edit protocols, MPLS, label switch path. Okay, and then we're going to do okay, so protect LSP from both link and node faults. So we'll enable that. Looks like we've got more options here, but that's just because you can toggle multiple knobs in a single command. So all of the options I have here are the same that I have here, because it's just knobs that you're selecting to toggle, and you can toggle multiple knobs at once. Okay, but let's toggle this node link protection knob. Do a show. There we go. And then we'll do top edit protocols RSVP interface GE001. Okay. Set link protection. Let's take a look at the help. So protect traffic with a label stacked LSP. Perfect. Okay, so now I've got link protection and link node protection enabled. Link node protection is enabled for the LSP, and link protection is enabled for the RSVP interface. Okay, so I've still got more than half my time remaining. So I think what I'm going to do is just destroy all the routers and then configure them all and just see how far I can get through wiring up this topology. I could also maybe go back and work on the last example, but doing that unfortunately would throw all my labeling out of order. Okay, so we're going to have a total of 10 routers. I think I can do that. I did have a problem with my license expiring, so I don't have the same number of vCPUs that I used to have, so I might not be able to run all of the routers. Well, we'll see how it goes. I'll keep an eye on the CPU and memory statistics. Alright, so we've got our 10 routers here. Their router, they're starting at router 0. We'll make router 0 router 10 because it's got a 0 on the end, but I'm not going to go through the trouble of renaming it. So let's arrange these routers so that it matches the documentation. Oops. Okay, router 4 goes on top. Alright, and then router 9. Router 2 and router 7. Okay. Router 9 looks good down here. Alright, so next is going to be router 1. Okay, and then router 6. So that's interesting. It looks like router 3 and router 8 are not used. And yet that appears to be the case. There's no router 3 and there's no router 8 in this topology. So that's kind of unusual. I'm not sure why they picked the host names that they did, but it's good news because every device matters when it comes to the memory and when it comes to the hardware that I'm using, because these images can be pretty taxing. Okay, so next step will be to cable everything up. At the very least, just cabling up the control plane to the forwarding plane. Okay, so yep, and I think the next thing that can happen is cabling everything together. So I can kind of go my own way on this. Let's start with 0 to 0. Okay, and they're all going to be labeled, so it's not a big deal. 2, 1, 2, 0. 2, 0. All right, so yeah, everything looks good. I'm gonna make sure I'm looking at the server summary. Okay, and there's like a weird bug where the server summary shows up like in a weird spot. So unfortunately, I can't show the server summary. I can take a screenshot of it. But yeah, why don't I do that right now? Just, it'll just be a snapshot in time, but I'll get to actually show it. Okay, so here's what I'm seeing. Unfortunately, there's a bug though where it doesn't show up on the second screen. But we can see we're really good right now. So let's get these going and see how that changes. And hopefully the CPU doesn't hit 100. It just hit 100. The RAM is pretty good, but here's what I'm looking at now. It's maxing out. It's still at 100. Kind of no surprise there. It's a lot of devices. The big surprise is that the RAM is such a non-issue. I almost wonder if spending money on RAM is kind of not even necessary. I'm gonna actually walk over quick. I'm gonna pause the video, walk over and make sure it's not like heating up or like too or like really loud. I'll be back shortly. Alright, I'm back. All I did was just walk over to the room with the server in it. I was expecting it to kind of be going crazy with the fans really making a lot of noise, but the good news is it's actually like quieter than it usually is now. It's really humming very quiet, which is a big surprise because the CPU is still stuck in the high 90s, almost all the way to 100%. So yeah, I'm not sure what's going on with that. Let's see if the devices are booting up. Yep, so devices are still booting up. So hopefully once they're all up, it won't maintain such a high CPU level. I do believe that booting up a device requires more CPU than just running it. But we will see. Yeah, no matter what happens, I'm just gonna cap this at the one video. I don't know, it's just, I don't want to give it more than one. So the next video is gonna be, look that up. The next video will be LDP protection. So it's going to be quite a bit of a shift because we've been focusing on RSVP, but this will be for LDP. Yeah, so I guess one thing I could be doing while this is up is just developing my configuration just in a Notepad++ file. Okay, so let's come up with the configuration for R6. So I think the host name will already be set, but yeah, let's not worry about that. Let's just focus on the configuration. So set interface GE, and I'm not sure what it'll be. Let's do X for now, and then we'll do family inet address. We can see these are all going to be in the 10.0/16 network. They're going to be subnets of that supernet, and I'm guessing they're going to be /30s. It doesn't tell you, but they all fall within that. So let's use it. Okay. Okay, so this is going to be from a different supernet. It's going to be from the 192.168 supernet. The other thing to notice is the X is in the third octet, so this .6 is going to be in the third octet instead of the last one, so it's going to be .6.1/32. Okay. So the other thing we're going to need, okay, well, I don't see any information about, oh, well, one thing that we know is since we've got MPLS, we are going to need IP addressing, we're going to need an IGP, we're going to need a signaling protocol. All of those things are required for MPLS. So even though it doesn't say to set up OSPF or ISIS, we know that is required since it is a prerequisite for an LSP. So let's go with ISIS. I haven't really used that lately. So I will need to enable family ISO. Actually, no, let's go with OSPF, just because they don't give ISO addresses. But we will need to enable family MPLS. Okay, and now we'll set protocols, OSPF, area 0, interface 6.0. Okay, and then set protocols, OSPF, area, traffic engineering. We'll add the loop back as well. Perfect. So next is going to be RSVP. Okay. All right. And we can just do interface all for OSPF as well. Might as well keep it simple. Okay, so the other thing that's going to be required, and it's just going to be required on this one, is a Ingress Lsp. So we can see, yep, we've got a dotted line here, so that shows the LSP path. So it starts here, and it's a ingress there, so it's going to be named. Now it's the longer dotted line, the shorter one starts here. But the longer dotted line is going to be named here, so let's do that. Okay, so now we'll need to set it to, and it's going to be 192.168.0.1/1. Okay, so yeah, I think that's all that's going to be necessary, at least to play around with many-to-one or link protection for LSPs. So yeah, we'll just go with that. Hopefully, oh, so it's not up yet. Looks like the CPU is still maxed out. Unfortunately, so a reason why the server wasn't going crazy, the fans making a lot of noise, is because yes, we're maxing out 100% of the CPU, but that CPU is just the virtual CPUs that we've allocated to this GNS3 virtual machine. So if we maxed out all the CPU on the Blade server itself, that would be going crazy, but we only maxed out the CPU allocated to one of the virtual machines hosted in the Blade server. And that virtual machine is not using all of the available CPU. We can go and look at the statistics of that. So here's the management portal for that. So proceed. Okay, so yeah, now we can look at the statistics. So you can see we're using half the memory, but you can see for the CPU we're only using 71% of the total capacity for the whole thing. But if we go and look at the individual machine, we can see that it is using 100%, actually over 100% of the available for this virtual machine. So that's why it wasn't going crazy with the fans and sounding really, really loud, because I'm only allocating 8 vCPUs. I used to be allocating 16, but my license expired. So I'm unable to allocate all of the CPU on my Blade server. So I probably could have paid a little bit less for less CPU. But I'm pretty happy with it. I mean, I paid less than $600, which is less than a gaming PC, a good gaming PC, and passing these exams will help my career a lot. So it's a good investment, I think. The problem with my license expiring is that it just takes a lot longer for the devices to boot up. Might even consider, just because I'm not really doing anything right now, because my lab isn't ready to go. So I might even just consider stopping the video. Maybe there's something I can find to do. I mean, I was working through what the configuration would have to be, but I'm pretty sure I'm done. I don't think it's going to need anything more than that. I can make configurations for the other routers. Yeah, so I don't think it's gonna be ready to go by the time, with enough time to really do anything significant. Unfortunately, that throttling down with my license expiring really does hurt, because I gotta sit and wait longer than 6 minutes for it to reboot, and 6 minutes was already quite a bit of time. So I think I'm gonna end the video here. Unfortunately, I think we're gonna need to go into a second video for this topic. I think that'll just be a good idea. I'll get more practice that way. So I'm gonna do one more video on this topic tomorrow, and that's gonna be just doing the best I can to complete this, creating those protected links here, and making sure that I have the LSP come up. I think that'll be a really good thing to just drive home some confidence with this subject, because I've spent a lot of time where the LSP hasn't come up and I just kind of panicked, and I just kind of felt really hopeless and helpless. And it was just because I forgot to enable family MPLS on the interfaces. So I think it'll help to spend one more video on this to kind of get my confidence back and believe that it's actually not that difficult to set up, as long as you remember to include all the pieces of the puzzle. Alright, so that's going to be the next video. I'll see you then. Thanks for watching.